Okay, all right, let's get started. And I think people who are joining in will share the video as well. Okay, cool. Are you guys able to see my screen? Okay, excellent. Okay, so what was the intention behind the I Believe in Doing edition, right? The July edition. So the goal was we start learning OOPS, and most of it is uh, revolving around the question of what is encapsulation, what is abstraction, what is inheritance, right? If you go on the internet, try googling or try to watch some videos, everything that's being explained is in terms of what it is, right? But then we wanted to bring in the right questions there of why, where, and how, right? Why do you need to use these particular concepts? Where, in terms of situation, where, what are the situations where you would need to apply this, right? And then yeah, I think one of them is asking, would this recording be available? Yeah, we'll post it. We'll post it and make an announcement on that. Shouldn't be a problem, right? So coming back to the right questions to ask, right? The why, where, and how. So the why and where come, why comes first, right? You have a code base, you start off writing code, and then you say, okay, is this, I've written code, it works, it functionally works, right? But then why should you even think about these oops concepts when you're writing code, right? Even before writing code, you should actually be thinking about designing the code and then getting down to writing code, right? So through these bytes, what we're trying to bring about is for you to learn the why, and then we've given examples of where they are applicable, right? In terms of searching for them or learning from the internet, when you go there, you would see examples like the animal or a car driving, not being aware of the internals of workings of a car, things like that for abstraction, right? But then when you sit down and start writing software, do you really have you really internalized those animal or car examples into the concepts itself, right? So we have tried to pick up real examples in the industry where these situations are really ripe for the application of OOP concepts. And then comes the how to apply it, right? So we've given, in our case, we've given the examples in Python, but they are just as applicable with Java or C++ or any other OOP language that you have. Okay, so let's get started here. So this is the Slido link where you can ask your questions. Sridhar is also here. We'll be monitoring the Slido. We'll also answer things if you post it on the chat window. That's okay as well, right? Feel free to ask your questions. We'd like to hear more from you. We want to make this as much of an interactive session as possible. We like to see if you had issues, if you ran into something, those things, as well as things like how effective was the learning? Did you think this was different? Would you sort of like to see more of those kind of things, right? Slido link, let me get the Slido link 1 second.
Yeah, I'll share it, Kiran. You can continue. I'll share the slide link.
All right. So yeah, Sridhar will share that. So we'd like to hear more from you. So feel free to start posting your questions either on Slido or on the chat window. Okay. Okay. So if you go down, so some of you who might not have started, this is for you guys. You have to log into Crio.Do. Once you log in, you go to the Crio.Do homepage. Once you go there, you will see the Bytes tab. Okay. So there will be micro experiences Bytes. So once you go to the Bytes, once you click on the Bytes, you will see all of the OOPS related bytes grouped together under the OOP foundations, right? So go ahead, pick them up. You can click on each one of them, right? Once you click on them, you can, there will be a button on the top right which says start your byte. You can just click on that. Very quick. There's no additional things that are needed. So you can just quickly click on it and then get started. Okay. So we have 4 of these bytes, like we spoke about in the initial session, and we are covering these 4 topics as part of those 4 bytes, right? Encapsulation, which is basically you are hiding the data, making it difficult for others to access that data, not really access the data, but to manipulate that data, right? So you're saying I am an object, I will be in charge of manipulating my data, and I'll be in charge of my current state. That is encapsulation. Abstraction is method hiding, where you're saying the external guys need not know what I'm doing internally. I'll expose a method to them and they can just come in and do just that, whatever is needed for them. All the minimum that they need to know in terms of the method signature is all I'll give to them, right? And then they need not worry about how complex of a code is there on the internal side, right? All they need to know is the method signature. They can invoke, they know what results they'll get, they can work with that. That is abstraction. Inheritance and polymorphism is not something that we'll cover in this session. We'll have one more session scheduled for Tuesday to go about that, right? So this is the focus for today: encapsulation and abstraction. Okay, so the first byte is that you'll get started with there in terms of the sequence is encapsulation. Okay, now let's try to understand what we are doing in that encapsulation byte in terms of the larger picture, right? Why we are saying this is a real software scenario. Okay, so picture this: you have an Amazon account, okay, and then you are a user, you've logged in, and then you have some user preferences. In this case, we are saying we are picking up two user preferences, which is your country of choice and your preferred language, right? So that can be done either through a web browser. You open up your laptop, you launch the browser, you open up Amazon.in tab, go to your account, user preferences, and change your language or country, right? But the same thing you can also do from your mobile, right? You can go to the Amazon app on your mobile, click on the user preferences there. Once you've logged in, you can check the user preferences. You can change your country and your preferred language, right? So this is something of an action that you can do in either places, either on the web or on your mobile, right? So now so this effectively has to transition or translate to some action on the backend server where your user preferences are finally being stored. Irrespective of whether you change it from your browser or from your mobile, it should get registered somewhere or stored somewhere, so that suppose you change it from the browser, right? The next time you log in from your mobile, the same preferences which you had set earlier should be visible on your mobile as well, right? So it has to be stored somewhere so that it's uniformly handled irrespective of where you're accessing it from. Okay, so this, in terms of our architecture for this particular byte, your browser tab where you've launched Amazon.in is your web application, and your mobile app where you're launching the Amazon app is your mobile application. Could be Android or iOS, right? So these are the clients. So these clients, when they send in their updated user preferences, suppose you had English and then you choose Hindi, that web application sends it to the backend server. This could be a bunch of servers, right? But then it hits somewhere on your backend, right? And there is a specific handler which is handling all the requests coming from your web browser. There will be a specific handler which is handling your requests coming from the mobile application, right? So it will hit here, and finally these handlers have to convert that and store it in this user preference place. This could be a file, this could be a database, anything else, correct? So what is the focus for this byte? Where this is the entire architecture in a simplified way, right? From the web application sending the user preference all the way to it being stored. So what is the focus? Where are we really working on in this particular byte? So if you see this is the part we are working on, right? We're not really showing any of the clients here. The request does not come from here, but we are looking at a part where this handler updates the user preferences. We are not even worrying about this part of the handler, which does a lot of other things, right? This could be some REST API request that is coming in. It opens up the REST API, looks at all those parameters, does some validation, sends a response back. We're not focusing on those things. The focus of this particular byte is where that user preference gets sent to whoever it is to be stored as a permanent thing, right? It has to be stored somewhere. So that is the part we are focusing on. So the request to store those user preferences would come from your web client handler, Android client handler, or the iOS client handler. right? So that is the focus here. So let's see what the problem is or where the encapsulation fits into this particular problem statement. Okay. So in terms of storing the user preference itself, we've simplified it again for demonstration purposes to store them in a file. In this case, a JSON file, right? So the user preferences come in from the client to the handler and then get stored in a JSON file. So if you look at this diagram, this user preference, which is being stored, is writing it to a JSON file. Okay. And this is what the JSON file would look like. These are the basic parameters that we are going with: the username, the user's preferred language, and the user's preferred country, right? There could be multiple such users. And this is the, so when we had this problem, right? So we said, now you have the option of storing a country and a language. In addition to just storing country and language plainly, you have to validate them. Meaning, you have to say, okay, if the user is choosing India, he should be allowed to choose only English or Hindi as his preferred language. If the user is selecting USA, he should only be able to choose either Spanish or English as his preferred language. Okay. So now there was one implementation like this where the iOS handler was there and the Android handler was there, correct? So what they did was they said, okay, we'll implement that validation, that requirement has come in. So both of them put in that implementation of validation, right? So they said, okay, this was the iOS handler. It said, when I update the preference, I'll do this validation. Country USA, it should be Spanish or English. Country India, it should be Hindi or Hindi or English, right? And then if that is not true, then I raise an exception and say, okay, this is not possible. You're not sending me preferences according to the rules, and goes away, right? So the effectively that change does not get persisted if this validation condition is not met, right? And the Android team came in and did the same exact validation, but what they did was there was a bug, right? This is not intentional. So when they were implementing it, somebody was in a hurry. They said user country India, user language Hindi, English, correct? And then they copied these two lines, pasted the lines, right? And they said, okay, now for US also I'll do the same. But what they forgot to do or overlooked was changing this language Hindi to language Spanish, right? This is a very real thing that happens quite often, right? We can say, okay, we need to do some code reviews to fix these things and other kind of precautionary measures. But there is an underlying problem here which needs to be addressed, right? It's not really just fixing a bug, but what was the source of this bug? As with all software development, we start off and say, for all the bugs, we do some root cause analysis, right? And then say, what is the real cause of this problem? One, the developer was in a hurry. He just put this in copy paste kind of error. He didn't pay attention, and the reviewers also did not catch it, right? But then, even if this code was correct, why is this code not so good? We are saying there is duplication of code. You can see that pretty evidently. Both the different handler teams have implemented their own validation, correct? So there is duplication of code. And we are taught from day one that duplication of code is not the ideal way to code, right? Any place, there may be some unavoidable circumstances, but in most places, if you are duplicating code, you're not doing something right, correct? So if that validation can move to one place, that is the best thing to do, right? Where multiple people can come in and use it, right? So, and why is this additionally bad? Now we are saying in addition to duplication of code, it's across different teams. There's an Android team which is doing it. There's a web application team that is doing it. And there's an iOS team that is doing it. Each of them, it's a huge company, right? There are multiple teams, tens of hundreds of people in each of those teams, in the Android team, in the iOS team, in the web application team, right? Each of them is writing their own handlers, right? So across all these people, across all these teams, there's prone to be some mistakes, right? So, and more importantly, who should be responsible to enforce these user preference validations, right? Is it the iOS handler, Android handler, or the web teams, right? Because they may not even know or have the expertise to say, okay, these are the user preferences and I should be validating them this way, right? The user preferences is being stored by some other guy somewhere else, right? But that uh, validation of those user preferences is happening in these handlers. Should they be really responsible to do this, right? So that the answer to that is no, right? Because any validation that is happening with respect to user preferences should happen within a module which is handling user preferences, not within a module which is handling the iOS requests, Android requests, or web requests, right? They should not be in charge of handling any of the user preference data. All they should be doing is invoking a method where this validation can happen in one place, correct? So now we start thinking about it, see that there is a root cause, and we say, okay, now we'll redesign this with encapsulation. What is encapsulation? Why are we even thinking about encapsulation here? As we spoke about it, user preference being in one place, having its own methods, and being in control of itself is encapsulation, right? If that were true, then these iOS, Android, and web handlers would not have needed to come in and do the validation on their side, correct? All of them would have just invoked this independent uh, uh, user preference module, which would do all the validation, right? So if you look at this, now we've changed this user preference into a very clean class. We say, okay, we'll make this independent, make it encapsulated, right? Hide some of the internal things, which are all my parameters, right? Username, country, language. So just something which is specific to Python here is the naming convention. There's nothing called private or public explicitly within Python, but the naming convention of starting something with an underscore, either a method name or a field name with an underscore, signifies that it is a private field, okay, a private method or a private field, which is what we've done here. The initialization is a private one. It can be initialized with by doing this. You can initialize the internal variables which are also not accessible outside, right? With this, you can say, okay, if there's no parameter passed, I'll just initialize everything to null. Otherwise, if parameters are passed, I'll initialize the values of all the data fields to whatever has been sent to me, correct? And now this is the important one, right? You say update user language, which is now saying everything that has to do with updating my private field, which is the user language, has to happen through this method. Okay. It says you will not be any external guy. You will not be directly accessing these variables. Instead, you will invoke me to do that, right? It says, okay, update user language. We would have created an object with the username, language, country, and say update user language. So what this guy does is he checks out the current preference, right? So he checks the current preference, which he gets from the JSON file where he's storing everything. That is where the persistent data is there. He opens that up, checks the data in there, and says, okay, now I'll update this guy's language and language and country preference, right? If that user is not yet there, I'll create him. That JSON file is the persistent database of all the users, their preferred country and language. So I'll open that up. If the user is already there, I'll update it. If the user is not yet there in my persistent data, I'll create a new set of data for this particular user, right? And the key thing here is this guy does the validation, right? Now the validation is happening within the right guy who is in charge of handling user preferences. Okay. So now how does this affect the other guys, the iOS handler, the Android handler, or the web handlers that were there, right? Okay, so this is the question. Who should really be implementing this? Now we know that we have a user preference team who's handling all of these things very cleanly. And now we say, now the important question is, this is asking where should it be done, right? The where question. We know that, okay, it's bad to replicate code. We'll do it in one place, but then the question comes up of where to do this, right? And the answer to that is it the Android team? Is it the iOS team? Is it the web team? Is it any of these? No, right? These guys are just in charge of getting the data and passing it to the user preference team. The user preference team itself could be tens or fifties of people, right? They are doing things by themselves. They are making sure that any validation that needs to be done, any new fields that need to be supported in user preferences is all being done. So effectively, the user preference team is the one who should be doing this validation. So if you are given just a simple requirement of saying validate the language and country data, right, in the user preference, where would you do this? That would be that is effectively the design question here, right? And the answer to that is it's better always to keep this in an encapsulated class, keep it independent, where multiple people can come in and use this. So how do you visualize this? Now that we saw the architecture that was there, which part we were focusing on, and how that validation being in different places affects the code, what kind of problems could arise, and what is the right way to do this. Now to summarize this, initially what was happening was this. The Android team had its own validation logic. The iOS team had its own logic. The web team, which was the browser handling the request from the browser, had its own validation logic, right? And the user preference just had update country, update language kind of a thing. And he would blindly write it to file irrespective of what these users sent. He was not doing the validation. Now this led to the problem, right? Repeat of code in multiple places, error prone, not really encapsulated. Suppose a new thing comes in, this guy does it, but these two guys don't do it. It becomes a messy thing. So now we've said this user preference will make it a very clean class so that objects of this user preference type can just be used by all of these teams. Okay. And it's put in some private variables and private methods, which only it uses, and some public methods, which is exposed, right? So all that these three teams or these three classes will know is update user language, update user country. This is the only thing that they will invoke, right? All of this thing is internal. It's all hidden. Hidden meaning it should not be accessed from these guys. If you're using something like C++ or Java, you would directly define these as private. So when you try to invoke this, it will just throw an error, right? But in private, but in Python, we just follow the convention of naming the methods and variables with this underscore, meaning they should not be invoked from the external entities, right? So the public methods are what we are talking about as the exposed ones. But more importantly, with encapsulation, the hiding is the part. The part about exposing public methods is more relevant to the abstraction, right? We'll cover that. But to understand this particular byte, the key thing is we are hiding the private methods and private variables. That is encapsulation. And we've seen what advantages it has, right? Any questions with encapsulation, or if this example is not clear, or if you've understood exactly this particular situation and you'll be able to apply this to other scenarios, right? Do you guys now have that kind of an understanding? Did this help understand encapsulation? I don't see anything on the chat window. Right. If you would need to further extend this, right, and say, okay, now I need to add even more languages, even more countries, like Ravinder is saying, right, it makes it that much more easier. You will do it in one single place in that user preference class, correct? Makes it very, very simple. So this is object oriented design, right? When you initially think about it, you have to think about the larger picture, the longer running sequence of things, more and more things coming in. How will it be more maintainable? How would it reduce the risk of errors? All of these things, these object oriented concepts come together to provide all of that. Can you please repeat that user preference will validate? Okay. Right? So what was happening earlier was the validation was happening in all of these places, right? The Android handler was doing its own validation for exactly the same thing. Same language country combination validation was happening in three places, correct? In terms of our files, we have just two of these implemented, but if there were three or even more, all of them would have implemented their validation logics inside their own class, right? But then moving that validation to this, the user preference class, makes it more put together in one place, right? Where all of these guys just can just use that particular method and not worry about the other things that are inside there, right? They won't even be able to access these things, making this user preference class independent. So all of them will come in, they'll just see, okay, this is what I need to do. I will call this update language guy who will do the validation on his side, right? Because he knows better, he knows best what is the preference that will be allowed, right? Yeah, cool. All right, let's move on to abstraction. Okay. So what are we doing with abstraction? With abstraction, we have a different example, a different real software scenario. Let's see what that is and understand what that is, right? So let's take an example of an e-commerce company. Okay. There are multiple products running there, multiple teams working in that company, right? For example, we have the inventory management system who are managing all the inventory that they have, right? Inventory is basically all the products. How are they storing the products? How many of those uh, uh, count of each product? Say, for example, you're talking about, say, washing machines, right? How many do I have? How many are in my physical inventory? How many am I storing in my godowns? And how many are being sold right now? And in order to say, oh, I need to have this much stock, how many do I need to order, right? All those things, that is the inventory management system. It's keeping track of all the things that are there, all the products that are available, how many are in stock effectively, right? And whenever the stock reduces, you have to stock up again. That's what this guy is doing. Then you have the vendor management system. A site like Amazon or Flipkart supports many vendors, right? So you have to manage all those vendors. You have to make sure that for a given product, you have at least two vendors, right? Otherwise, if one vendor goes away, you will not be able to offer that product to sell anymore, right? And you have to manage all those vendors, make sure they provide service, make sure they make sure they get paid on time, all these things, right? And you also have the logistics system. Once the user places an order, where does the packaging happen? When does it get delivered? How do I get a delivery receipt, right? As well as if it does not get delivered, how will the refund happen? All of those things are logistics, right? So these are just three of the different things that are needed. There are many more, right? But what we are driving at here is, within a company there could be multiple products, right? And which are sort of being shown here. And all of those products have to have some configuration to support themselves. Okay. What do we mean by configuration? Right? So the products here, the examples of products here are that vendor management product, the logistics management, the inventory management, right? And say, for example, vendor management. The vendor management needs to have a configured value of, okay, I have so many vendors. What is the credit, maximum credit before the vendor actually provides me with the goods, right? How much will I keep as the outstanding credit, right? If he is beyond that, he is not supplying goods, I will have to cancel out that vendor, right? What is the vendor's minimum rating where I have to where I have to continue using him as a vendor? If he gets to a 1 star, I say, okay, I'll give him some time and then I'll remove him. That so the rating here would be, say, 1 star, no longer I should no longer support him. Or credit limit, say 10,000 rupees, right? Or what are the maximum vendors per product? Given one particular product, I don't want to have too many vendors. It becomes difficult, right? So things like that, those should be configurable. Somebody at the back says, okay, now this was 10, I need to change this to 5. So it should be configurable in one place where each of the products read their configuration and act accordingly, right? If it was the logics management product, it would say uh, there is some allowable discount overall for these users, right? What is the max allowable discount? Beyond that, I should not be giving discount. So if anybody is saying I want a discount more than that, it should not be allowed. So this will be configured. It says, okay, and I have the list of all the vendors that are supported on my platform, right? It should have a list. So anybody new comes in, we should be able to add to this list, and then the product knows that there are more vendors to support. Similarly, a warehouse list. Where are my warehouses? What kind of products is each warehouse storing? Right? All that should be configurable, right? Anybody who updates the data here, the product should all get that updated data. So in general, there's a lot of configuration that is involved. For example, the inventory management guy says, okay, what is my maximum storage capacity? I cannot order more than what I can store, right? So yes, there is a limit on that. What are the maximum pending orders, right? If so many pending orders beyond this, I have to take some action, right? So that has to be configured somewhere where you can take some action. Default reorder timer, right? So my goods are being sold at this constant rate. By default, I'll always place an order for 10 more washing machines every 10 days, right? Something like that. So multiple things should be configurable. Each of the products need its own set of configuration parameters, which can anybody can at the back end, they say, okay, now this team, we need to make this configuration change. It may affect configuration across all of the products, right? So somebody does that change and all of these products seamlessly read the new configuration and start using that new configuration value, right? For an example, if this guy had these three parameters, if the vendor management product has these three parameters, he would have configured this somewhere. Say for our simplification purpose, we are saying we've stored it in a JSON file instead of a database, right? So the credit limit is say 100,000. The minimum rating for a vendor is 2. Below that, I'll have to take some action. Maximum vendors per product is 10. If any other new vendor comes in and says, I'll sell the same product, I should not let him on the system, right? I should not be adding him to the system, right? So those kind of things are called configuration, and all of them in this particular problem, what they're doing is they're talking to a configuration manager. So since all of them have a need for the same functionality, the company does not want to have multiple different configuration managers. It says, I'll have one configuration manager. All of you products just talk to that configuration manager. Whenever you want to update your configuration, go tell him to write the config. Whenever you want to get or fetch the configuration, go to that configuration manager and say read config, right? That simplifies my life as a company because all of the products are using the same code, correct? So this is effectively like this config manager is become an encapsulated entity, right? So it says, okay, you all of you guys go use this guy. Each of you don't go out and implement your own config manager because that would not be very maintainable. Okay. So now initially what happened was all of these products said, okay, I want to store my data as config files, right? Which in case if I want to share with someone else, I can just share that config file itself. So everybody was initially doing JSON files, right? A single type of file. So at that point, this is what the structure looked like. So we don't really have the code, anyone else to trigger this, right? So we are writing a main.py, which will trigger the actions that the products need to take. So the products, so these effectively are different classes, right? So product one has a read config, write config. Product two has a read config, write config. In fact, he himself may have 2 or 3 different sets of configuration, right? So he'll always say read config and he'll give a specific file name. He knows which file name to store one kind of configuration, and a second kind of configuration, he can say read or write that different configuration file name, right? So all of them are using it. This is what the code looks like. In order to show this working, we've written this main.py, right? All that the main.py is doing is it is saying there is some config guy which is the vendor hardware guy. So this vendor hardware team is there. They have written their own file to store their configuration and read their configuration. In this case, the configuration they're storing is the configuration which was there in some SQL database, right? They want to store that and read from there, read and store, right? So the main is saying, okay, I'll test this out. I'll invoke these guys similar to what in a real product, this this vendor hardware product would be called by some other guy, right? Some other place would be invoking this, but here we are doing it from main. But internally, what this guy is doing to read and write is using config manager, which is what our architecture is saying, right? So he calls the config manager write config, and the parameters he passes are, okay, this is the file name where I want you to write my config, and this is the data that I'm passing for you to write. And when you're reading, it says, okay, read this particular file, return to me that data, which I will use for multiple purposes, right? So all he's doing is very simple here. There's a config manager which supports read config and write config. So this is the config manager code, correct? On the right here, it supports the basic functionality. It allows you to read config and write config. And what it does is it writes to a JSON file and reads from a JSON file. and it returns back the data to whoever is asking, right? So it is very independent, right? All it does is it knows the file name. The users are explicitly telling it what file to write or read. So it takes that file name and puts it into either the file or gets the data from that file and sends it back. Okay. So this, each of the teams have this thing. Each of the teams have their own product where they're using the same configuration manager. So that is what, ignore the main.py in terms of the learning for this particular byte. What we should focus on is each team. This is the vendor hardware.py, right? So if you go and look at the code base, you will see a couple of more teams have their own Python files, their own product classes. But the common thing is all of them are using this config manager write config manager read config. Correct? So let's move from here. So now the new requirement comes in and says, instead of doing this JSON file alone, support for JSON file alone in the config manager, some teams say, now you're forcing us to use that one single config manager, but now I don't want JSON files. I want XML files for whatever reasons, right? They say XML files are much easier to store, faster to read. They provide a long list of explanation. And some product teams say, I want your the company config manager to support XML file now, right? So this is what they say, okay, this is what it looks like. Your JSON, if it was like this. XML is more structured. It would look like this. Now the configuration manager team gets this request and says, okay, I'll go ahead and implement support for you. And it adds more methods. Initially, it only had read config. If you recall from the previous one, the config manager only had support for read config because by default it was doing JSON. Now it adds methods separately for JSON and XML. So in the method, it says, okay, I'll separate out this functionality. That read config that I had earlier has become read config from JSON. That write config that I had earlier has become write config to JSON, right? And now I've added two more new methods which support the XML variety of the config file. Okay. So now the vendor hardware team, right, which was earlier using JSON, right? Now it has to change. The change it has to make it earlier, that the change that it has to make is, earlier it was just calling config manager write config. But now this guy has to change and he has to know what kind of file he is writing, right? So he has to say write config to JSON. This guy has to say read config from JSON. So now what is happening here is each product team now needs to know what kind of a file it's doing and appropriately call the method where the method name is telling it. The method name is also suggesting what kind of file they're reading or writing, right? So the vendor hardware guy says, okay, I'll use the JSON variety. I'll change my method names to this. And then the logistics hardware guy comes in and says, okay, now I'll use XML. I'll use write config to XML, read config from XML, right? So now this works, right? So the requirement is satisfied. It's already encapsulation, right? They're already just calling methods provided by config manager. So why is this bad, right? Now we are saying this requirement came in, it has been implemented, it still looks clean, right? But why is this bad? So adding support for even more types. Say right now we've done JSON, XML. Say a future requirement comes in, say CSV files or some store written database and whatever, right? In that case, this particular class that we have, this config manager class will start growing. Now it is not very clean encapsulation either because it is now doing multiple things. It is handling XML file configuration, it is handling JSON file configuration, it will do the CSV file configuration, database configuration, all those things, right? The class is starting to get bloated. It's not doing one functionality very cleanly, right? That is one problem. The second problem is we saw that we saw this, right? Initially he was calling write config, but now this guy has had to change it to write config to JSON or read config to from JSON. So anytime the guy wants to switch from one particular file type to another, he has to change all the lines where he is reading or writing these configuration files, right? Which could be happening multiple times across the entire product code, correct? So they would end up changing this all the time. Every time they make a change of file format, they have to go to hundreds of places and make that code change. So it's not extensible. A new format comes in or they switch formats, It's a very cumbersome thing. Again, this is error prone. If they miss in one of the places, there could be an error, right? So what is a better design? This is where abstraction comes in. Okay. So that whatever the clients are calling, right? That clients meaning this vendor hardware team or the logistics team or any other team, right? Who are using the configuration manager. Those are the clients of configuration manager. So the client should be unaware of what is happening behind the scenes, right? They should be able to just say write config or read config, and this config manager side of code should be able to handle that. It should know whether to write in JSON or XML or CSV and should take care of it. So what is the best way to do that? If we start, yes, sorry about the noise. So if we start adding more and more methods to this config manager, it becomes very bloated. So what we are doing here is setting up this config manager as an abstract class, right? So we are saying anybody who needs to read or write config, these are the things that we'll support, right? So the clients will only know that I can call read config, I can call write config, right? But now, how do we support XML and JSON in this case? Now this config manager says, I'll keep it very clean. I'm an abstract class. I'll expose only my read config, write config to the clients. They need not know what's going on behind the scenes. They need not know whether they are actually trying to do JSON or XML or CSV, right? So the way we implement this is we say, okay, so we'll write some children classes effectively, which are implementing this interface, right? So this has now become like an interface, right? So this is only defining the methods. If you're talking about this in terms of Java, this is an interface. It says these are the methods I have. Anybody who wants to implement these two methods is wants to support the same thing as the configuration manager does, is free to do this. He can go ahead. He can implement his read config in any way he wants. He can implement his write config in any way he wants. But from the client side, they will only see read config or write config. So here we've split it up into a configuration manager XML and a configuration manager JSON, correct? So those two guys are doing the XML handling. So those two guys are doing either the XML or JSON handling, right? But the signature is exactly the same. They say, okay, read config or write config. So any client that comes in will still be able to seamlessly call read config or write config, not worrying about whether it's read config from JSON or write config to JSON, read config to XML. They need not worry about it, right? So now what has happened is this config manager code is very clean. It just defines what should be exposed to the clients. And internally, what has been implemented is two separate classes, one for XML, one for JSON, are implementing their own version of read config and write config, which will come into effect, correct? When the clients call this. So now, say I am a client and I want to say my file should be stored in XML, right? That guy still has to tell it somewhere. So how is he doing it compared to previously? So what the clients are doing now is very clean. They're saying the configuration manager I want is configuration manager JSON or configuration manager XML, which is this particular class, right? So they're saying I want configuration manager XML or configuration manager JSON. So they do this, and anytime they switch, this is the only line they have to change. Internally, they always keep calling write config or read config, but this object knows that it is a JSON object, or this object knows, this config manager object knows that it's a XML object. And internally it knows when the write config is called, because I am a JSON config manager, I will write in JSON or I will read from JSON, right? So now the advantage is whenever, so yeah, these two advantages. So whenever the client wants to switch formats or a new format is introduced, he just has to change this one line of code where he's initializing the config manager, right? He does not need to change any of these method calls, right? So the functionality also, right, is very maintainable. Any changes that the config manager XML team wants to do to its handling, it can do internally without impacting any of the clients. So the client interfaces remain the same, more importantly, right? Which exactly is abstraction. So when the clients need not worry about what is internally being done, that is abstraction. So let's quickly recap between encapsulation and abstraction as well, right? Encapsulation is data hiding, right? Making those methods, making those fields and some of the methods private. So it is data hiding. Abstraction is method hiding or complexity hiding, right? So what we are doing, so the complexity hiding, meaning the user or the client need not worry about how the things have been implemented in the backend. Correct. All they need to know is the method signature for them to invoke it, and any changes that happen on the in the implementation of these classes, right, should not impact the clients. The client should have a clean way or a well-known exposed interface or method signature which they can invoke. That is basically abstraction, which is what this particular situation needed as well, right? So by separating out this, designing this, redesigning this using abstraction, what we've done is the clients have been helped. The clients need not make too many changes every time something changes. Any of the complexity is hidden from them. Even the complexity of whether it is XML or JSON that's happening is also hidden from them. The only place they need to specify that is the place where they are initializing their particular config manager. Okay. So what if you want to visualize this abstraction, this is what it looks like. I should probably call this, and if you're working in Java, this would be an interface, right? So the config manager has become an interface. So there are two new classes which have been introduced, config manager XML and JSON, which implement this particular interface, right? So these two guys implement this interface. This by itself does not provide any functionality. It just defines the clear public methods which the clients will see. So the client only needs to know this guy, the methods offered by this guy, and they can just call read config and write config. And depending on whether they have initialized their object as an XML config manager or JSON config manager, the corresponding methods in these classes will get invoked, right? But all they need to know is this method signature in this interface class. Okay. So abstract methods are there. Implementation of abstract methods are there in the corresponding classes which are implementing that particular class. Cool. Any questions? Abstraction slightly more clear. You'll be able to apply this to some scenarios now, be able to pick up scenarios and write it in a blog, which is the thing we want you guys to do, right? To make sure you've understood, we want you to pick up a software scenario, apply some of these OOPS concepts and write it out. Yeah. Any questions? Please do ask some questions.